This video is for your subject Science and Technology, Paper 1. In this video, we are going to study the Chapter 1, that is Laws of Motion.
Students, we have studied the concept of motion. Motion means that an object is always changing its position. Newton studied the motion of an object and he gave us a set of equations for the motion. Now, when an object is in motion, there are different quantities that are associated with it. Okay, the different quantities that are associated with it are displacement, now displacement is directly associated with motion because when there is displacement, then only we can say that the object is having or is in motion. Then the next quantity is velocity. Next quantity is velocity. When an object is moving, yes, it has some kind of velocity. Next is acceleration. Acceleration is dependent on velocity because acceleration means rate of change of velocity. And time. The time is for the time taken by the object from reaching from the initial position to the final position. Now these are the quantities that are related to an object that is in motion. Newton gave us equations which helped us understand the relationship between these quantities for an object that is moving in a straight line. Okay, so these equation will be for object that is moving in a straight line or having linear motion. Now let us see what are the equations given to us by Newton. So the first equation is V is equals to U plus AT. The second equation is S is equals to UT plus half AT square. And the third equation is V square is equals to U square plus 2AS. Now, in these equations, you can see there are four variables. The variables are U, V, A, T and S. Sorry, there are 5 variables. Okay. Now, what is U? U is the initial velocity. U is the initial velocity of the object, which means the velocity when the object is at the start position. It can be anything. It can be 0, it can be 4 meters per second, it can be 6 meters per second, it can be anything. This U means from what period of time you are starting to calculate or you are recording the velocity. Okay, V is the final velocity. V is the final velocity. A means acceleration. A means the acceleration. T is the time period. T is the time period. And S represents displacement. And S represents the displacement. So these are the three equations of motion given by Newton for an object traveling in a straight line. Now, if you notice the first equation, In the first equation, we have got u, v, a and t, but there is no displacement. Okay, in the first equation, the variables used are v, u, a and t. So this equation gives the relation between velocity and time. This gives the relation between velocity and time. Now, if you look at the second one, in the second one, there is no velocity. There is no final velocity. So this relation gives the, this equation gives the relation between displacement and time. This gives the relation between displacement and time. And if you notice in the last equation, there is no factor of time. So this gives the relation between displacement and velocity. Understood, students? So what we are going to do is we are going to derive these three equations graphically. Students, let us start deriving the given equations. Now, the first equation which we are going to look at is the equation describing the relation between velocity and time. Now, since we are going to derive these equations graphically, let us look at the graph over here. Now, according to this graph, the vertical line is for velocity and the horizontal line is for time. The initial position or the initial velocity of the object is considered at this point D, which I have noted by U. After some time period, the velocity is at point B. Okay, so this is the displacement done. Now at point B, the velocity is V. At point B, the velocity is V. This is the final velocity. Now, in order to reach from D to B, it has taken some time. The time is denoted by this segment OE. Okay, and this time we have taken as T. Now, so initial velocity U is equals to OD is equals to AE. Now, students, we have got two rectangles over here. One rectangle is on the top, that is C, B, A and D, and the second rectangle is D, A, E and O. Okay, so in rectangles, the opposite sides are congruent. The opposite sides are congruent. So the initial velocity U is represented by DO. So DO is equals to AE is equals to U, which is the initial velocity. Then the final velocity is this, what, OC. So OC is equals to, you got one more, BE is equals to final velocity V. Then you have got time period E. OE is equals to DA is equals to CB is equals to T. Students, keep these initials in your mind because we are going to use the same initials for all the three equations. Okay, now let us move into deriving of the equation velocity and time. Okay, now the relation between velocity and time is given by acceleration. Acceleration is change in velocity upon time. Change in velocity upon time. Okay, now we let the acceleration to be A. Let the acceleration be A. Okay, we'll consider acceleration be A. Now the change in velocity, we have got the change in velocity. What is the change in velocity? Change in velocity will be this part, है ना? This is the initial velocity and this is the final velocity. The initial velocity is this much and the final velocity is this. So how will you get this change in the velocity? The change in velocity you'll get will be BE minus AE. BE minus AE upon OE. Change in velocity upon time. So A is equal to, what is BE? BE is V minus, what is AE? AE is U upon T. You multiply T over here, so you'll get therefore A into T is equals to V minus U. Therefore, you take U on this part, so therefore you will get V is equals to U plus AT. So this is your first equation of motion. Students, let us now derive the equation describing the relation between displacement and time. Students, when we did the displacement graph, we have understood and we have studied that the displacement of an object is given by the area of the quadrilateral formed below the graph. Okay, the displacement, this object is in motion, so it will have some displacement. We'll say let that displacement be denoted by S. Okay, now this displacement we can get this displacement by finding the area of quadrilateral DBEO. DBEO. Okay, now what kind of quadrilateral is DBEO? DBEO is a trapezium. Okay, and area of trapezium is half into sum of parallel sides multiplied, sorry, I'll make it this way, sum of parallel sides multiplied by height. Sum of parallel sides multiplied by height. Okay, so according to this, a displacement is denoted by S. Sum of parallel sides, which are the parallel sides? OD and BE are the parallel sides. So this will be half multiplied by OD plus BE into height. Height is the perpendicular distance between the two parallel sides. So we'll take height as OE or DA. We'll take DA as the height. Okay, we'll take DA as the height. So S is equals to half multiplied by OD. OD is U plus BE. BE is V into T. Okay. Now, we do not want V, but we know the value of V in a first, according to the first equation, V is equals to U plus AT. V is equals to U plus AT. So what we are going to do is we are going to substitute V is equals to U plus AT. So S will be half into U plus AT into T. Okay. Therefore, S is equals to half into, this will be 2U plus AT multiplied by T. I'm continuing on this part. So S is equals to, this half gets multiplied inside, so this becomes U plus AT upon 2 into T. Therefore, S is equals to, U into T is UT plus half AT square. So this, students, is the second equation of motion. Students, there is one more way of finding the or deriving the second equation of motion. Now let us look into this. We know displacement is the given by the area under the graph in the graphical representation. Now we know displacement is given by the area of this trapezium dBEO. Now you can directly apply the formula for the area of the trapezium, or you can split this trapezium into two geometrical figures. You get one triangle and one rectangle. So this can also be written as area of quadrilateral DBEO is equals to area of triangle DAB, DAB plus area of rectangle DAEO. DAEO. Okay. Now let us look at the area of the triangle and area of the rectangle. Area of triangle is half into base. What is the base? Base is BA, or we will take DA. DA into what is the height? Height is BA. So area of rectangle is triangle is equals to half into DA into BA plus area of rectangle. So area of rectangle I'll take as length into breadth. What is length? OE. And what is breadth? AE. Okay. Now let us start substituting the values. So this will be half multiplied by, what is DA? DA is T into, what is BA? BA we don't have the value, but what is BA? BA is the change in velocity. So how do you get the change in velocity BA? BA will be V minus U. BA will be V minus U, or for your understanding what I'm going to write BA as BE minus AE. So this BA I have written as BE minus AE plus, what is OE? OE is T multiplied by, what is AE? AE is U. Okay. So displacement is given by S. Now S is equals to half into T. BE is V minus U plus UT. Okay. Now we know the value of V. Now substitute V is equals to U plus AT. So instead of V, I'm going to write U plus AT. So S is equals to half multiplied by T multiplied by U plus AT minus U plus UT. So this U and this U gets cancelled. So what you're left with is, therefore, S is equals to half AT into T. So half T into AT plus UT. So S is equals to UT plus half AT square. So students, this is one more way to solve the equation between displacement and time graphically. Students, let us now derive the equation describing the relation between displacement and velocity. We know the displacement S of this object is given by the area of quadrilateral DBEO. Now quadrilateral DBEO is a trapezium. So S is equals to half into sum of the parallel sides. The sum of the parallel sides is OD plus BE. OD plus BE multiplied by height, that is DA. Therefore, S is equals to half multiplied by OD. OD is U plus BE is V into dA is T. Now students, since the relationship is between displacement and velocity, we are supposed to substitute for time. So we know acceleration is equals to V minus U upon T. Okay, therefore I can write T is equals to V minus U upon A. Okay, I've just cross multiplied over here. Now what I'm going to do is I'm going to substitute this value in this equation. So I'll make this as equation 1. I'm going to write substitute T is equals to V minus U upon A in equation 1. Okay, so your equation 1 changes to this. S is equals to half multiplied by U plus V into the value of T becomes as V minus U upon A. Okay, now this A and 2 will get multiplied over here, so this becomes 2 AS is equals to U plus V. See, this is V minus U, this is U plus V. What I'm going to do is I'm going to change this to V plus U and V minus U. Okay, so therefore S is equals, therefore 2AS is equals to, I'm just repeating the step over here, V plus U into V minus U. Okay, therefore 2AS is equals to, this is like A plus B, A minus B, so you're going to write V square minus U square. Again, I'm going to take this U square on the left hand side, so this becomes 2AS is equals to, 2AS plus U square is equals to V square. So after rearranging, we get V square is equals to U square plus 2AS. So this is your third equation of motion. I hope you all have understood all the three equations and how to derive them graphically.